Зашли, посидеть в удобных креслах, может быть, даже что-то послушать.
So hello again, and today I will be speaking about device fingerprint. I will be speaking about how good and how bad it really is. I'm not even going to ask you about those of you who don't know much about device fingerprint. You obviously know that we collect some characteristics from a device. In actual fact, when we say device fingerprint, we are talking about browser fingerprint. I will be doing similar things, but they are not much different. In actual fact, we'll be speaking about three main topics. We're speaking about what's good and what's bad, and we'll speak about how it works and why we actually need it. We'll start with the actual philosophy. We'll try to find the difference between the good and the evil. We'll start with the evil part. This topic has been demonized a long time ago. The use of fingerprint for fraud. Everyone uses it. Social media, corporations, agencies, everyone does. So what they would like to get? They would like to tune a digital pattern of the user to sell or resell it to someone. Sell it to Big Brother. How they do it, well, everyone understands how they do it. On each page, on each resource, we just need to put a piece of code with JavaScript. If it's a social media, it's not that difficult to do. If it's an agency, the owners will do it for us. I'm going to skip the evil part. It's all clear. Before we tackle this good part, let's remember history. Before we start with the history, let's imagine that we have some kind of financial organization. For simplicity, let's call it a bank. It can be a company, a payment system, a store, but it should have two important features. It should have users getting some financial services. So it should be all about the money. Or miles, for instance. It's also kind of a currency. And another important thing, these operations should be done from the name of a customer, which is important. Everything started when computers were huge, and the only way to interact with a bank was offline mode. So in order to get such a service, a person should go there, wait in a line, and the bank was trying to identify this person with the analog tests, and at that time was the golden age for information security of the bank, because everything was really fine those days. Unfortunately, the internet was growing and developing, and people started learning more about using it for some financial operations. It really added more headache for internet security. People preferred to use what was called the untrusted data channels to get access to such banking services. And very fast it became obvious that the login password combination was not quite enough when we talk about the money. So maybe you remember such things. I started talking about The second factor, they're almost offline tools, because to use them, you just need to take them somewhere. You take a passport, you go to the bank, you receive it there. What's inconvenient about it? Did you have a scratch card? I used to have one. You had to go to the mail office, to the post office, to pick one up, which was worse. I actually had a scratch card. What was a problem with it? When twice a month you enter your online bank, you need to find that thing. You needed to find a coin to scratch the material of the scratch card. Then there were some odd activities added. In the English-speaking environment, friction term is used here. To get that service, you need to go through some friction. People started getting nervous and people started running to the bank with less friction. It's a classic balance between balance between convenience and protection. That's what all the turbulences are all about, but convenience really wins. Let's go back to our days. Imagine our abstract bank gets an online access, and to interact with it, you just need to enter a login, a password, and the bank knows everything about the user. We have matches between the logins and people, so it should all be done by the name of the person. So the bank does not need to track down the user activities. The bank knows everything about the user. They had given their name, the address, the phone number, the number of accounts, so you don't need to track this person down, but remember that balance. Convenience and protection. So we need a second factor, at least in Russia. What are we going to do next? The bank needs to verify that the user is the one but we can trust this user with only a certain level of confidence. We can check a cookie file. If the user has been with us and we see the cookie file, that's true. They've checked us for the second time. We cannot ask the user additionally, because it adds more friction to it. Call the user, give them the token is a bad thing to do. It will upset the user. So what can we actually do here? Basically nothing. What we can do here is just to measure the risk for that particular user. And you can measure the risk by indirect signs, showing that the user is actually the one he's giving himself away for. If we go back to the traditional and well-known methods, it's the IP and the device fingerprint that we will discuss. But before we start talking about it, I should explain why device fingerprint is not a bad thing in banking environment. You don't need to track down the users. It's not done for tracking, it's done for different purposes. It's for managing trust with the user. The point of fingerprint is not to catch the bad ones, but to increase trust for the good ones, to annoy people less. And another term comes up. Frictionless user experience. This is a term which is very popular in Europe and the United States. How can it be done? It is quite obvious. To make a fingerprint, we need to collect some characteristics from the browser. And the browser can explain quite a lot if you ask the browser to do that. There are different ways. Numbers, lines, families, canvas, groups. They also have their own features. Well, first of all, there are plenty of those. I would call them non-universal. In some browsers they do exist, in some browsers they don't. And they may be different from one another. And they have some hierarchy. And the operating system is a good sign. It could be used as a top level of hierarchy. Obviously the type of a browser can be used here as well. But what about level 3? We don't know why you're using this particular hierarchy. It's also unclear. They can be dependent on one another. They're not fixed. Today we can see a bunch of them from one device today and a few the next day. We cannot trust them that much because the collection of such things is done by JavaScript, which is not done in a non-trusted environment by the user. So we don't really know what is happening there.